In this question, the function g dot dot r /3, so all reals excluding the value 3, mapped onto R, where g of x equals 1 on x minus 3 plus 2, has an inverse g to the minus 1. The rule and domain of g to the minus 1 are, and one of these. So the golden rule when you're finding the inverse, swap x and y, is always a good thing to write. So this is y equals 1 on x minus 3 plus 2. So if you make it x equals 1 on y minus 3 plus 2, then all you have to do is rearrange this to make y the subject. So first step here, I'm going to minus the 2 from both sides to get that, 1 on y minus 3. So what I'm going to do here is just swap all of that with all of that. So it's a bit like when you have something like x equals 1 on 2. If you go 2, multiply both sides by 2, you get 2x equals 1, and then divide both sides by x, these cancel and you end up with 2 equals 1 on x. So the x and the 2 swap positions. So it's a quick way of doing this one. So writing this over here, so you end up with y minus 3 equals 1 on x minus 2. So a little shortcut there, and then adding 3 to both sides, you end up with y equals 1 on x minus 2, and then plus 3. So plus 3, and so this is g to the minus 1 of x. And so there you go, that's the inverse function. And you have to also find, well, first of all, looking here, 1 on x minus 2, so it could be a, it could be b, and it could be e, so a, b, or e. So the domain, all right, so the domain of this, because there were no restrictions other than, really all you're looking at is this to get the domain. So are there any values that x can't be, and it can't be 2. So if x equals 2, 2 minus 2 equals 0, 1 on 0 is undefined, so the domain is going to be all reals except for the value of 2. So that's the only value that x can't be. So, and that looks like it's A up here. Second question. So which of the following functions does not have an inverse function? So for an inverse function, the main thing is that the original function is 1 to 1. So f of x has to be 1 to 1 for it to have an inverse. So really all you have to do with these is make sure or find the one that isn't a 1 to 1 function. So starting with A, and so f dot dot, I'm actually not going to write it out, it'll take too long. So this domain 0 to infinity of the absolute value of x minus 2. So what does that look like? So you're going to have x equals minus 2, something like that, and then this bottom part is reflected up like that, and that's the y-axis, this is the x. So from 0 to infinity, so 0 to infinity, so here's x is 0, 0 to infinity is going that way. So if that's the graph there, just ignoring this part down here, getting rid of that, you can see that if you draw a horizontal line through this section here that has positive x values, through there, you're going to have one y value. That y value might be, say, 1, and the x value here might be 1 as well. It's a very small one in there, and this x value here might be, say, 3. So those 2 points, this is going to be 3, 1, and the other one's going to be 1, 1. So what you've got here is 2 x values for 1 y value. So that's like 2 to 1, which is a many to 1 function, many to 1 function, which is not 1 to 1. So it looks like this is the answer right here. This one, so this one does not have an inverse function. So that's pretty easy, that one's done, but I'll run through the others. And it's always a good idea when you are doing your practice to just work through all the options, and that way you get good at all the possibilities that they give you. So B, f dot dot r mapped onto r, f of x equals x cubed. So this is just your basic x cubed, your positive x cubed graph that goes like that. And it is a one-to-one. No matter where you draw a vertical line or a horizontal line, it only goes through one point. So that means this one is one-to-one. So therefore it does have an inverse. C f dot dot, this domain is mapped onto R where f of x equals the square root of 9 minus x. So your basic square root graph, and just marking in x and y here as well. So your basic square root graph, and because it's minus x here, it means the graph's going that way. And when x is equal to 9, 9 minus 9 equals 0. Square root of 0 is 0. So y is equal to 0 when x equals 9. So that means it starts here and it does something like that. And that's the x value of 9, and that's just kind of heading off into that direction. And any horizontal line that you draw or a vertical line is only going to go through one point on the graph. So therefore this is one-to-one and does have an inverse, even with this domain here, minus 3 to 3. So that would be, say, here to here, and that would be just like that up to this point here. That section of the graph there, which is still one-to-one anyway. So that one does have an inverse. Part D, f dot dot r mapped onto r, where f of x is equal to x to the 1/3 plus 4. This is really just the same as the cube root of x plus 4. So just the cube root of x looks like that. And then when you add 4 to it, it moves it up 4 like that. When x is 0, cube root of 0 is 0, plus 4 is 4. So that's the y-intercept. And these both head off slowly into approaching positive infinity in both directions. And this heads off down to negative infinity in both directions. And this is a one-to-one graph. So that means it does have an inverse and all real, so that graph goes forever kind of thing. So it's one-to-one at every point on that graph. So that one does have an inverse. So part E, f dot dot r mapped onto r, so domain of r, and this is a linear function. So 3x plus 7, passing through 7 and pretty steep, so that's 7, that's y, and this is x. So straight line, same gradient everywhere, vertical line or a horizontal line will only pass through one point on the graph, so this is also one-to-one. So that also has an inverse function. So all of them have an inverse function because they're one-to-one except for A. So A is the answer to this question.